So, good afternoon, everyone. We will wait few minutes. Let's see if some other students are joining. So, before starting this class, this live interactive session, uh, previously I have taken 3 live sessions. So, if you misses those sessions, you can have this through the link that has been provided from this NPTEL site through this mail, and you can have a look. So, if you are having any doubt on this, you can raise the concern to me. So, good afternoon, everyone. Whether this screen is visible to everyone? So, before starting these classes, if you found any doubt about this, any question or any concept, please let me know either by opening your mic, or you can just put a text in the chat box, and I will try to clarify your doubts. So also, like in the previous 3 classes, in this live interacting session, what we will do is that we will try to solve some question regarding this fluid dynamics, and how the concept that has been already discussed in the class has to be come into this numerical problem, how this concept is going to going to help us in solving a problem. So this thing we will do in these classes. So we will have some theoretical question and some numerical question, and all these question will comes from this underlying concept. So I will try to explain this thing through this concept. So let us start today's session. So this is our fourth live interacting session, and I am Niloy from IIT Bhubaneswar, a PhD scholar, and the course on this fluid mechanics is taken by this course instructor Professor Subhashis Datta from IIT Bhubaneswar, and I am your teaching assistant for this live interacting session. So, first let me introduce about this course. So, this course, Fluid Mechanics, is an interdisciplinary course, and the students of mechanical and civil engineering and even chemical engineering, they find the role of this subject in problem solving and in real life application. So, if you are going to design a plane or a jet, anything you are going to design is based on this concept of fluid mechanics. So this subject is nowadays quite essential to solve this real life complex problem. So all so from this so in the initial 3 class we have gone through the basic concept, and in the last class also what we have in the week 3 what we have done is that we have gone through this Reynolds transport theorem, and thereafter we try to solve numericals on this conservation of mass and conservation of momentum along with this theory. So, if as many of you have enrolled for these courses, so what I will suggest you that please register for this exam, as this will help you to understand how much you have learned from these courses. So, as 15th was already this last date, but they have extended, but the NPTEL has extended this last date till 18th August. So, I am going to start this session. In this session, these are the main 3 topics that we are going to discuss. First is the conservation of momentum, application of this conservation of momentum. As we already have discussed about this momentum equation, now we will see few more application based problem on this concept. Next is a quite vital theory, which is the Bernoulli's equation, that is very much important in fluid dynamics. And third is its application. So we will start with numerical problems. So this numerical is based on this concept of what I will discuss today. So before discussing about each question and what concept comes into this scenario, I will give you 1 minute time to try to solve, as I think that most of you has gone through the lecture of Professor Subhashis. So I think that you can, some of you can be able to answer this question. So let's see if any of you are able to answer this question. So the first question is, this energy gradient line is at, the first option is at a distance of v square by 2, which is the velocity hat from the above the hydraulic gradient line. Next is the sum of the kinetic head and datum head, and third is it coincide with the water surface in the free surface flow, and D is all of them. So please try to answer this question. I am giving you 1 minute, and after that I will explain this concept for you. So please try to answer. So you can answer by switch on your mic, or you can just put a text in your chat box, whatever you feel comfortable. So Shivam has answered B, option B. So Sachin, can you try? Sachin said B. So not exactly. So let me clarify this concept for you. So what basically this concept is? Just a minute. Let me. So I think that all of you know this concept of Bernoulli's equation. So first let me write this equation. So what this equation tells? This equation tells that P by rho g plus v square by 2g plus z equal to constant. So this is the mean. So actually each term represent a specific head. Okay. So the first one refers to the pressure head. So whatever be the energy at a point, say see anywhere, say this is a pipe. Okay. So if I talk about this point 1, so whatever be the pressure head means this pressure per unit volume, and this is the, sorry, not per unit volume, per unit weight. So this is the velocity head, and this is the datum head, or someone also call it as potential head. Whatever you want, you can call it datum head or potential head. So this is basically, that means the sum of this pressure, energy, velocity head means the energy related, that is the kinetic energy, and this jet represents this potential energy. So the sum of the pressure energy plus kinetic energy plus potential energy should be constant. That is the fundamental of this Bernoulli's equation. Okay. So now this hydraulic gradient line, there are basically mainly two types of gradient line. This is hydraulic gradient line, HGL. I represent it as HGL. HGL means this pressure head plus this datum head. Okay, this is the hydraulic gradient line. That means it only considers this pressure terms and this datum term, whereas the energy gradient line EGL, I represent it as EGL, represents this pressure term, pressure head plus velocity head plus datum head. So the whole energy is known as the energy gradient line. So now the question is, this EGL, energy gradient line, is what? So just see, if I consider this as equation 2 and this is equation 1. So 2 minus 1 gives EGL minus HGL, this equal to velocity head, right? So EGL equal to HGL plus velocity head. That means what is velocity head? Velocity head is v square by 2g. That means this energy gradient line should be above this hydraulic gradient line, and at what distance? At v square by 2g. So the correct option is option A. So is this concept clear to you, both of you? Just let me know whether this concept is clear to you. If there is any question or any doubt about this, please let me know. So basically this hydraulic gradient line represents this pressure term plus datum head, that means this potential term, whereas this EGL line represents all summation of all these three heads. So Shivam and Sachin, is it clear? Okay. Okay, so we are moving to this next question. So before moving to this next question, let me clarify one thing, that please this fluid dynamics part is quite important even for your engineering perspective. So if you are going to sit for a placement of campus or anything, they will ask you fundamental concept about this Bernoulli's equation, conservation of momentum. So try to understand what this concept is. So always remember, if someone asks you what is this Bernoulli's concept, just tell whatever be the summation of the pressure energy plus kinetic energy plus potential energy at a point that should be constant. That means if we take any point inside the domain, the summation of all these things should be same. So that is the concept. So the option A is the correct answer. So I am moving to this next question. So in this question it was asked, which of the following statement is or are true with respect to the kinetic energy correction factor. So these are the four options. Please try to answer. Do not worry about this whether it is correct or not. Just try, just attempt this, because it will help you to clarify this concept. So Shivam has answered option A. That is the most flow encounter in practice are turbulent for which alpha is close to 1 and hence alpha is ignored. So Sachin said option D. Yes, Sachin is correct. Option D is the correct option. So let me explain this thing for you. So see, if I talk about this energy equation, what is this energy equation? While deriving this equation, what this scientist or researcher have considered in case of this Bernoulli's equation, that is the velocity is uniform across the pipe section. Say if this is the cross section, if here this is the velocity v, each and every point it should be v. So that is the fundamental of this Bernoulli's equation. But if I talk about the reality, so in real life this velocity varies. Okay, so here if it is v, it is v in each and every point it should be v. But in a real life scenario represented by black line, this is real life scenario. What will happen? The velocity, if this is v1, this velocity is more, and if we move toward this wall, so this velocity will goes on decreasing. Okay, that means v1 is greater than v2, greater than v3, greater than v4, like that. And even sometime at the wall it is zero, velocity is zero. Similarly on the other side, it's a almost symmetric nature is observed. So that is our real life scenario. So see, I have in the previous slide I have talked about this velocity head, right? This velocity head is v square by 2g. Okay, so that is a ideal case. That means this is equivalent to this case. So but here this velocity are changing at each point. So for this what we are doing, we are taking a constant alpha before, and this whole term is known as velocity gradient in real life. So this alpha is known as a correction factor. That means this is a factor that will help to eliminate the effect of this change in velocity. Okay, so that is the concept. So this alpha is for real life scenario. So why this velocity is changing? Generally in case of turbulence flow, this velocity is changing. So the first option is this: most flow encountered in practice are turbulent, for which alpha is close to 1 and hence ignore. So see, in turbulent cases what will happen? Turbulence means there is a quite disturbances there. So in that cases we consider this value as 1, so that this Bernoulli's equation can come again into this scenario, and often we ignore this term. That means this alpha is ignored. So option 1 is correct. Let us go to this option B. These kinetic energy terms are often small relative to other term in energy equation. Yes, see, in case of why generally what happens in a flow, say if the velocity is quite less, then the kinetic energy term is quite less, right? So and this pressure term, there are three terms: pressure term and datum term. So if the pressure terms and this datum term is quite high, the value, say if this pressure head say this is 1000 and this datum head say 500. Okay, and if you find this kinetic head, say it is 2, so see, compared to 1000 or 500, this 2 is quite negligible. So what we do, we just ignore this kinetic energy term. This term we are ignoring. So option B is also correct. And in laminar flow, alpha is significant, and it is necessary to include alpha while analyzing this flow fluid problem. Okay, see, in laminar problem, you know the difference between laminar and turbulent flow, right? So in turbulence flow there is disturbance among this fluid layer, whereas in laminar there is no such disturbance. So it remains constant throughout the fluid path. So that is the basic difference. So in laminar flow, this disturbance is less. So you have to consider this value. Say I am giving you an example. Say this V1, consider this V1 equal to 10, this one 8, 6, 4. So if you average out these thing, the average should be less than 10, right? Say this velocity is 10, 8, 6, 4. So if you average out this velocity, it should be less than 10, right? But in the laminar, it is always almost in case of laminar, what will happen if this is 10, this is almost 10 to 10, almost near about 10 or 9.9 like that. So what will happen, the average of this one should be equal to 10 more than this one. So that means in laminar cases this alpha should be included. That's why the option D is the correct answer. Okay, so either this concept is clear to you. So Sachin, good, so you have answered it correctly. So let us move to this. Okay, thank you for confirmation. So let us move to this third question. So it's a numerical question. So what is asked in this question? In this question, it is asked that the water flow in a 10 centimeter diameter pipe at a velocity of 0.90 meter per second. The mass flow rate of water in the pipe. So you are asked to find out this mass flow rate. So you remember this concept of mass flow rate. So I am just giving you a hint. Where you find this concept of mass flow rate? You have studied about this continuity equation, or I can say conservation of mass equation. So in this conservation of mass equation, what is there? So the mass flow rate at the inlet should be equal to this mass flow rate at the outlet if there is no such accumulation in the system, right? So this mass flow rate, that means m dot equal to, what is the formula? Rho into q flow rate, or you can write it q means rho a v, where v is the velocity. So that is the formula. So based on this fundamental formula you can find out. So please try to solve. So in another point, please remember one thing. In any numerical problem, first try to convert this unit. Say if somewhere if it is given in millimeter and in the answer it is asked to find in meter, so you have to convert each and every term in a single terms. Like if it is in meter, each and every term should be in meter. So please consider this point. So Shivam has answered option D. Okay, I have to check. So Sachin, please try to solve. Okay, so let me solve this one for you. So no issue. So say if I again recap this concept for you, Sachin. So what is this? conservation of mass energy to mention. This conservation of mass energy mention and of mass. So see, it is a domain. Domain means a fluid body. If a fluid is entering, say with the mass flow rate m1, okay, and say if m2 dot is coming out, so either what this conservation say that m1 whatever is entering this system, this is summation of whatever the mass entering into this system minus whatever be the mass coming out of the system, there should be equal to 0. I mean, there is no change. If consider, that means it should be equal, but sometimes it is happening that something is accumulating in the system. Say if 10 kg is entering this system and 8 kg is coming out, so 2 kg is staying in this system. So that means this thing, this is inlet outlet accumulation. Okay, so inlet mass flow rate, outlet mass flow rate is equal to accumulation mass. So that is the concept. So how we will find out this mass flow rate? The formula is either mass flow rate equal to rho into q. Q is the flow rate in terms of volume, and this is another formula where it is rho AV. That means this Q is equal to AV. That is our fundamental formula, right? So up to this, I think it is clear. If any doubt, just on your mic and you can ask. So in this question, what is given? Diameter is given. So say diameter D. This means what is the diameter? This is 10 centimeter. So I convert it into meter. That means this meter, right? So what I need to find out mass flow rate. That means m dot equal to what I know, rho A V. So area I need to find, because I know the density of water rho is 1000. Okay, so diameter is given. I can find the area as it is a tube pipe. They are mentioning about a pipe. So area, cross section area is pi by 4 d square. Okay, that means pi by 4 into 0.1 square. And what is the velocity is given? 0.9. So they are giving velocity as 0.9. It is in meter, so no need to convert. So I can easily write 1000 into pi by 4 into 0.1 square into 0.9. Okay, so if you calculate this thing, you will get it as 7 point, I think you get this answer. So there should be in kg per second. Why? Because this velocity is in per second, so the answer should be in per second, but in the option it is given in minute. So what I need to do, if you convert the second into minute, you have to multiply into 60 kg per minute. So if you multiply, you will get the answer. This option D is therefore our correct answer. So now it is clear, Sachin. Okay, thanks for the confirmation. So I am moving to this next one. So it's a fundamental question. This Bernoulli's equation is an equation of what? Either it's the conservation of mass, conservation of momentum, conservation of energy, or conservation of angular momentum. So I think both of you can be easily able to answer this question, right? I will give you 30 seconds for this one. So in the first slide I have explained about this thing. So please answer. Yes, very good. So both of you have answered it correctly. So that is the conservation of energy. So why? Because I have told there is a summation of the pressure energy plus kinetic energy plus potential energy or datum energy related to this datum head. So that's why this Bernoulli equation, significance of this Bernoulli equation. Now say if sometime it is asked from where this equation comes. So basically this equation comes from this first law of thermodynamics. Remember this thing, this equation comes from or derived from this first law of which is this energy conservation. So in terms of sometimes just the question can be asked, this Bernoulli equation is derived from four options can be given. So in this four option, first law of thermodynamics can also be given. So just remember this thing. So what are the three terms? Please remember these are the pressure term, kinetic term, potential term. So these are the three terms. 1, 2, 3. These are the three terms that is incorporated in this Bernoulli equation. So I am moving to this next one. Next question. So this is also based on this concept of this Bernoulli equation. So what this question told that this in a venturimeter which measures the flow rate of a fluid in a pipe, the pressure difference between the wide and the narrow section is due to this four option. So see, actually in venturimeter this types of arrangement is there. So if this is 0.1 and this is 0.2, so say that this pressure difference between 1 and 2 is due to what? Among these four, just use this concept of Bernoulli equation and you will be able to answer this question. So I am giving you 1 minute time. So Sachin say that option C, differencing temperature. Sachin, try to just I am giving you hint that it is based on this. See, whenever you find this term, flow rate, velocity, pressure difference, so you just try to correlate it with this concept of Bernoulli equation and conservation of mass, that is the continuity equation. So continuity equation and Bernoulli equation you try to understand. So now you try to answer. So difference in temperature is not the answer. Sachin said option B. What about Shivam? Shivam also said option B. Yes, it's option B. So see what as I have told that just remember this concept of this. So this is 1 and this is 2, right? So in the Bernoulli equation, if I apply Bernoulli equation, total energy, what is the total energy? I know that this is for point 1. Say this pressure is P1, velocity is V1, by 2g plus this is z1, this is point 1, this is for point 2 it is p2 by rho g plus v2 by 2g plus z2. This is the one, this is the energy total head, this is head equal to this is head. So from this Bernoulli's equation 1 and 2 should be equal. Okay, so what is datum line? Say this is the earth, this is the ground. Okay, so this is 1 point, this is 2 point. So from this distance this is known as z1. So if I consider this ground as a reference, so this one is z1 and this one is z2. So what I got, this z1 equal to z2. Okay, so if I, that means if I equal this to 1 equal to equation 1 equal to equation 2, so this z1 and z2 should be cancelled out. So what I will get, p1 by rho g plus v1 square by 2g, this equal to p2 square by rho g plus v2 square by 2g. So we are asked to find the pressure difference between this void. This one is void, that means P1 minus P2 we need to calculate. So I can write P1 minus P2 by rho g equal to V2 square, that is square is there. Okay, I just write for to write the square, V2 square by 2g minus V1 square. So see, or I can write P1 square, what I can write, P1 minus P2, this equal to rho g by 2g V2 square minus V1 square. Okay, so g's cancel out. So what exactly this thing, that is the pressure difference is proportional to the change in velocity. So that's why option B is the correct option. So this is the mechanism that is used in a venturimeter. Okay, so that is the concept. So I think I can move to this next question. Can I? Okay, I am moving to the next one. So in this question, what is say, in a steady flow system, the momentum flux correction factor is used to account for what? So the same concept I have explained a little bit earlier in a previous question. So I think if you understand that question, now you can able to answer this one also. Please try to answer. I am giving you 1 minute. This is a correction factor. So where this correction factor, when this correction factor comes into this scenario, just try to recall this scenario. Okay, good. Yes, both of you have answered. That is non-uniform velocity distribution. Yes, right. Because as already I have explained about this thing, that in real life scenario, this velocity, if in an ideal scenario, if the velocity at each and every point is v, but in real life, as we move toward the wall, it will decrease. So that's why a correction factors come into the scenario. So option B is the correct option. Good. So I am moving to this next question. See, it's a quite important question. You will find this question many times even in GATE. In GATE exam about 5 to 6 times in the last 12 year this question comes in different forms, not exactly like this, but the concept is same. So the question is based on this assumption of this Bernoulli's equation. What exactly this assumption in this Bernoulli's equation, that thing you need to know. So I am giving you 1 minute time to try to answer this one. So which of the following is not an assumption? So Shivam is saying option D, and yes, Shivam, sorry, Sachin is saying option D, and what about Shivam? Hmm, Shivam is saying option C. So no, Shivam. The correct answer is option D. So Sachin is correct. So please remember this assumption. I am writing this assumption for you. What are this assumption? Even in if you are in BTech in semester exam, these types of question can come assumption. So the first assumption is it should be a steady flow. So I am explaining each and every term after writing this thing. Next is an ideal flow. The third is an rotational flow. Fourth is a inviscous fluid. Fifth flow is along streamline. Next is then incompressible fluid. So these are the 6 assumptions. Okay. So now try to understand what exactly these terms mean. So if I talk about this TD, what exactly is TD? TD means the flow doesn't changes with time. Okay. So incompressible means density is constant. So see, if I talk about this option A, the flow is steady, it is correct. So the flow is incompressible, it is also correct. Next is there is no energy losses due to friction. So that thing also, because it's an ideal fluid, it is mentioned, that means no loss. So it is also correct. The fluid density varies with streamline. See, here the point is density varies. If the density varies, then it can't be incompressible. So that means option B and option D is contrary to each other. So this option D is the correct option. And another thing is that the flow, always remember, the flow is along streamline. The flow, not the fluid density, the flow is along the streamline. That means what exactly is streamline? Streamline means the change in if there is pressure too, there should be variation in pressure. If here if the both if the pressure at this end and this end is equal, then there is no such flow. So there should always be a pressure difference between these 2 points for this Bernoulli's equation to use. Okay. So please remember these 6 assumptions. Hmm. So I think now I can move to this next question. So again in this question, so this is also based on this Bernoulli's equation. In this Bernoulli used in the pipe flow, each term represent. So I know that each term represent an head, that is pressure head, kinetic head, datum head. But what exactly head means? So that is the question. So please try to answer. So I think Shivam, you understand the mistake in the last question. Okay, so it's good to hear. So now try to understand this. So Sachin is saying it's energy per unit mass, and Shivam is saying energy per unit volume. So, but none of this answer is correct. So why? Just let me clarify this thing for you. See, in the Bernoulli's equation, if you remember, in the pressure term, I represent this is P by rho g plus V square by 2g plus z, this equal to constant, right? This is the equation. So now this is pressure, okay? This whole term is known as, say I represent these two pressure head, right? So in the numerator this is pressure and the denominator this is rho g. What is rho? Rho means density, density into g. So in the density, if you see in the density means mass by volume, okay. So rho g basically means m by v into g. What is mg? Weight. So that's why this equation represents energy per unit weight. So always remember one thing: in case of fluid, we consider only density, not the mass. Either we consider density or mass flow rate, not the mass. Okay. So that's why the option C is the correct answer. So is it clear, Sachin, Shivam? Yes. Okay. So I am moving to this next question. So this question is that the pressure head and the kinetic head of water flowing through a pipe of diameter 60 centimeter are 50 meter and 4 meter respectively. So both this pressure head, that means P by rho g, that value is given as 50, and kinetic head that is d square by 2g is given as 4 meter. That means this value is also given, and the diameter is given, that is 60 centimeter. So what is asked to find? So determine this piezometric head of water at the cross section which is 5 meter above this datum line. Okay, so see, I think that I haven't discussed about this piezometric head. So piezometric head basically means this pressure head plus datum head. That means this hydraulic gradient line, you remember? So this hydraulic gradient line and this pressure and the piezometric head both are equal. Okay, so I am writing hydraulic gradient line so what is it? It is basically this pressure head plus datum head. So that is the concept. So please try to answer. So I am giving you 2 minute time. Okay, Sachin says, okay, Sachin. Okay, I will explain this for you, but let's see what others are. So Shivam said option A. Hmm. So, okay, let me clarify this concept for you. So, what exactly? See, each and everything in this equation comes from this Bernoulli's equation. P by rho g plus v square by 2g plus z, this equal to constant, that is always true, right? So the first term is this pressure head. I know this is pressure head, this is velocity head, this is datum head. Is it clear? So if I add all these three, say this is pressure head na, so there is basically two concepts. uh, Energy gradient line. The energy gradient line means the total energy. That means total energy head. So this whole term together is known as energy gradient line or total energy head, right? And if I only take this term and this term, then it is known as hydraulic gradient line or piezometric head. So that is basically a name given. So summation of all these three terms is known as total energy head, and summation of pressure head and datum line is only known as piezometric head. So that is the thing. So in this question, the piezometric head of water at a cross section 5 meter above the datum line. So I just erase this thing. So the piezometric at a cross section है तो. Say pipe is there in the question. What is given? A pipe is there. So its diameter is given. Say its diameter is given 60 centimeter. That means 0.6 meter. Okay, so and 50 meter is this pressure rate. Say this is the point, 1 point. So pressure head, that means given what is given? Given P1 by rho g, this equal to 50 meter, and what is given? V1 square by 2g, that is 4 meter. Okay, it is given. And what is it? Determine the physiometric height of water which is 5 meter above the datum line. That means exactly datum line is in the ground. If it is in the ground, this point 1 is at a distance of 5 meter. That means this is Z1. So in the question Z1 is given 5 meter. Now up to this it is clear. So what is asked? This physiometric height. So I can write physiometric height, this equal to what is P1 by rho g, no velocity should be there, plus Z1. So P1 by rho g is 50 plus Z1 is 5. So the answer is 55 meter. So the correct answer is option D. So is it clear? So what Shivam has answered, he has answered the summation of all these three. That's why he has said option A. So is it okay, Shivam? And Shochin said yes, okay. Thanks for the confirmation, Shochin. Okay, also Shivam, I understand this concept. So see, is this question 9 is a little bit tough for you. So in the next question, I think you will be able to answer this question. This is a fundamental theory question, not a numerical question. So please try to answer. So what is given? The which of the following equation is based on the fact that the mass flow rate at any section remain constant? So these are the four options. So please try to answer. I am giving you 1 minute time. Sachin answered option B. So let's wait for Shivam. Shivam is still thinking. Shivam, try. Okay, Shivam is also saying option B. Yes, it's correct. Because as already I have discussed this thing. So still for the others, as these videos will be uploaded in the YouTube. So if you misses the first three classes or any concern about this, you can have a look into this YouTube recorded video of this live session. So this mass flow rate is this thing. So if this is a fluid domain, what I have said, if I take any line, any two lines, say this is a black line and this is the green line. So if the total mass that is flowing through this point, if that is m1 and if that is m2 dot, then both of these should be equal. That is the concept. So that's why this option is continuity equation. So that's the mass flow rate at any section. So in the black section, if the mass flow rate is m1 dot, in the green section it should be m1 dot. So that is the concept. So I'm moving to next question. So it's a numerical question and it is based on this concept what you have studied till now. So I am giving you 2 minutes time to solve this. So before starting, let me clarify this question for you. What has been asked in this question? So in this question, it is given a large tank is open to atmosphere is filled with water to an height of 8 meter from the outlet from the outlet tap. A tap near the bottom of the tank is now open. So the tap is open now and the water flows out smooth and the round outlet. So the outlet is a circular outlet. So determine the maximum water velocity at the outlet. That's a quite interesting question. So I am giving you 3 minute time because uh, it's a tricky one, but it's based on what have you understand. If you clearly understand this Bernoulli's equation, then you can attempt this question. So you both understand the question, right? So you have doubt, Sachin, right? You can see the outlet is not small. How should the velocity change? Okay, okay. Let me answer. So see, why this thing? See, whatever in the BTech level, this question is mainly on this BTech level. So why it is smooth and round outlet it is given? Because they are not considering this correction factor. So if this, what is the question? Just a minute, let me check your question once again. So what you said, what happens if the outlet is not smooth or has friction? how would the velocity change? So see, if the outlet has friction, so what will happen? Say this is the normal outlet. If there is no friction, so what will happen? The velocity at any point is v, as I even at the near to the wall it is v. So but if there is friction, say if there is friction, so what basically friction is? Friction means it opposes the flow. So because of this friction, if the velocity here is 10, so near to this it is say 9. If you move further it is 8. If you move further it is 7, it is 6, and accordingly at the wall junction maybe it is 0 or near to 0. So that thing is happening if the outlet is not smooth and round. So the velocity will changes. So say if I talk about a velocity, in general scenario, I consider this flow is uniform. That means at each and every point the velocity is v. But if it is rough or it has some friction, then the velocity is changing. So we have to take out this average or even integration. You see, in the integration, why we do integration? Because this is varying in a field. So in that case, even you need to do integration. That question, this which you have asked, for this we need to do integration, or we need to find out the point at each and every, say in this point we have to find here, and for each and every point we need to find out this velocity. So in this way this velocity changes if it is not smooth. Is it clear, Sachin? So so I am giving you, can I now can you able to solve this question? So Shivam is saying option C is the answer. So what about Sachin and others? Can you try, or can I solve this for you? Okay, I am solving this for you. So see, if I draw this problem, what is given? Say this is the outlet of the tap, or this is the tap. So what is water is there in the tank? So what is the height of the height is given 8, right? And this one at the bottom. So you need to find out the maximum velocity at outlet. That means it is asked to find v at this point. Okay. So what I do this, I will take one point here, and the next point is here. This is 1 point, this is 2 point. So you need to you are asked to find v2. So what exactly this Bernoulli's equation tells? So the total energy had at one point, at any point, should be constant. So I can say that this energy had at 1, this should be equal to energy had at 2, right? Yes. So energy had in 1, I can write P1 by rho g plus V1 square by 2g plus Z1, this is equal to P2 by rho g plus V2 square by 2g plus Z2. This is the equation. So up to this it is okay. So see, given one point, so where is the one point? This one point, say it is open to the atmosphere, so that means this P1 is equal to P atm, atmospheric pressure, right? And it is, and at this point 1, whether water is moving? No. So I can write V1 this equal to 0. And Z1, and talking about this Z1, say see it is 8 meters. Say if I consider this as the ground, okay, so that means Z1 equal to 8 from this ground. And similarly, if I talk about this P2, this is 2 point. So this 2 point is also exposed to atmosphere, right? Because the tap is open. So that means pressure at this point should be equal. And you are asked to find V2. And what about Z2? So see, Z2 is this red line, that is the datum line. So there is no distance, so Z2 is equal to 0. So up to this concept is okay, Sachin? Another? Up to this, any confusion? Please tell. So you understand why these P1 and P2 both are P atm? Okay, so I am solving the rest part. So see, these now as P1 and P2 both are equal. So this thing and this thing will cancel out, right? And this V1 is 0 from here. So this is equal to 0, and Z1 is Z2 is also 0. So what I will get, in place of Z1 I can write 8 equal to V2 square by 2g. Now you can calculate V2 equal to 16g. Okay, so you can calculate, so and you will get the answer 12.53 meter per second. So option C is the correct. So please understand this concept, because similar types of problem I will give you to solve. So is it okay? Any confusion? NC, Sachin, Shivam? Okay. So whenever in another thing, please remember how in an exam how you will able to solve these types of question. So if in a question, say if the pressure is given, if they talk about this atmospheric pressure, velocity, distance, and all these things is given, so you remember that here Bernoulli's equation must be applied, must have to be applied. And if in this question, if it is still only velocity is given, or no height is given, only velocity is given, then maybe happens that you need to apply this continuity equation. So basically in most of the problem you have to find out the solution either using this conservation of mass equation, that is the continuity equation, or Bernoulli's equation. If you know this concept clearly, you will able to solve each and every of such types of question. And say in some question, if it is asked to find out this force, so in which equation you will find this term force, that is the momentum equation, then you need to go for this momentum equation. So that terms in the question, if this terms is present or not, you need to check this first before going into this solution. So now I am moving to this next question. So in this question, what is asked? A horizontal water jet of velocity is given, and cross section of 0.01 meter square, that is meter square here, not m2, it is meter square, strikes a vertical flat plate and is turned to flow parallel to the plate. If the density of water is 1000 kg meter cube, calculate the force exerted by the jet on the plate. So here force they need to ask. So basically it is the conservation of momentum equation. So I think you remember this conservation of momentum equation. I am just giving you a hint. Uh, Force equal to mass flow rate into velocity. Okay, that is the concept. That means if it is a fluid, say this is a fluid flowing through this line. Just remember this thing. So if I draw one line, this is section 1 and this is section 2. So summation of force at 1 and summation of force at 2 should be equal. That is the concept of conservation of momentum. I think this concept is clear. So now try to solve, everyone. Shivam and say everyone. Sachin has already answered option B. Okay, let's see. I am giving you uh, 1 or 2 minutes to solve this one. So Sachin option B. Rest to so Shivam also option B. So it feels good that you at least try to answer this question. And see, will you try? Or okay, you will try, and in the meantime, I will solve this question for all of you. So let's see whether option B is correct or not. So I am erasing all these things for you, but I think the fundamental of this conservation of uh, momentum is clear to you, right? So what is given in this question? The first thing is that what is given in this question. Given velocity is given, that is 20 meter per second. Okay. Area is given, that is 0.01 meter square, and density also given, that is rho is 1000 kg meter cube. Okay, that is given. So I need to calculate the force. Also, what I have said, that this force is equal to mass flow rate into velocity. So mass flow rate means m dot into velocity. So how I can find out mass flow rate? M dot means rho a v. Rho is 1000, area is also known as 0.01, and velocity is 20. So what I will get? I will get 200, right, kg per second. So m dot I got it as 200 into velocity is 20. So kg per second into velocity, that means force I know into it is in Newton. So that is 4000 Newton. So option B is the correct option. So all of you are right. So any doubt up to this? Answer is clear, everyone? So I am moving to the next one. Okay, I am moving to this next question. If you have any doubt, you can raise your concern by opening your mic, or you just put a message there. So I think some question is there. So it's a good question. So you said why we have taken only the momentum in the direction normal to the plate. Say, see, in the momentum equation, only in this momentum equation, just a minute. Generally, in a momentum equation, say I am erasing this part, right? So, if there are three axes, say x, y, z. If I talk about this conservation of mass equation, always remember this is for a certain point, it is irrespective of direction. That means in x, y, z and all these direction is coming into this scenario for this mass conservation equation. And even for this energy conservation equation, you have to take, say volume is there. Okay, a volume is there. If it is a mass conservation equation, you have to take the mass entering from here, 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 and all these direction you have to consider in a single equation. Similar is the case for the energy conservation. But for the momentum equation, there are three equations. One is x direction momentum equation, and another is y direction momentum equation. Next is z direction momentum. There is no such one equation for all these three. So that in this question, that's why it is said that the force exerted by the jet on the plate, that means it is a perpendicular direction they are saying. So we only take this momentum in the perpendicular direction. But if it is for energy, then we need to consider this change in this parallel direction, or in the y direction, z direction, and all these things we need to consider. If it is asked to find this change in energy or change in mass, then we have to consider. But for only force or momentum, we have to consider a certain direction. You got this point, Sachin? Have you got this point? Okay. So let's remember this thing, but for this other two, it is irrespective of direction. So this is for question, this is another numerical question. So this is quite interesting question. So in this question, what is asked? A pipe carrying water has a reduction in diameter from point. Initially, the diameter was larger, and after that, it got reduced. It's like a nozzle. So if the velocity of water in the larger section, at the inlet, it is given 2 meter per second. So determine the velocity in the smaller section. So the see what an interesting point is that they mention that you need to apply both this Bernoulli's equation and the principle of continuity equation. So now I think that you can answer. So if it is not given that apply Bernoulli's equation or continuity equation, still you have to apply this equation. Why? As I have said, first you need to check whether this velocity is given or not. Anything about, since a pipe is carrying water, say a pipe is there. So check whether this Bernoulli's equation is required or not, because there is no details about pressure is given or datum line is given, right? You can still apply, but check whether is it really necessary or only the continuity of equation is sufficient to solve this question. So use your concept. So I am giving you 2 minute time to solve this one. So Sachin say option B. Others, please try to answer. So see, these types of question is quite important for exam point of view and even for GATE. So if you are preparing for GATE, so whether everyone of you are from BTech, so Shivam is from BTech. So see, if you are from BTech and if you are wish to apply for this GATE exam, see, if you forgot about other concept, if you understand this continuity equation, momentum equation, and this Bernoulli's equation, you you can bring at least 4 to 5 marks in the GATE based on this concept. Because most of this fluid mechanics concept is based on this thing. So Sachin, the answer to this question what Sachin has given is option B. What about others? So Shivam is saying option C. So let us check. So see, as I have said that only what is given a diameter. If I draw this diagram should be like this one, right? If this is 1 point, this is 2 point. So diameter D1 is given zero point 0.3 meter and D2 is given 0.15, that is half of the initial diameter. Largest section velocity is given, that means V1 is given 2 meter per second and nothing, no other details is given. Say velocity is given, diameter is given. So if diameter is given, that means indirectly they are giving area, right? I can calculate area. So what is area? Area is pi by 4 into d1 square. Similarly, a2 I can find pi by 4 d2 square. Okay, so I have to apply, so I am applying continuity equation. Why? Because no details on this pressure is given. I can apply Bernoulli's equation, but since these details are not given, so I initially go for this continuity equation. So this continuity equation, what it said, summation of m1 dot equal to summation of m2 dot, means the inlet and outlet. So what is at inlet? At inlet there is rho a1 b1, at outlet it is rho a2 b2. As density is same, so this is cancelling out. So this v2, I need to find out v2 as mentioned in the question. v2 is with a1 by a2 b1, right? Okay, so that means v2 a1, as I have already get pi by 4 into zero point 0.3 square, this one is pi by 4 into 0.15 square and v1 is 2. So this one is cancel out, so 30, this is 2 times, that means total if I calculate, that is 4 into 2, that is 8 meter per second. So option A is the correct answer. No, here there is no need to apply this Bernoulli's equation. Only using this principle of continuity equation we can find out the solution. Okay. So I am moving to the, I think that most probably Shivam, you have misunderstand, you just, there is square there in this term, so you most probably mislead in this part, that's why you got this answer as 4. So check this one. Okay, I'm moving to the next question. So this is another question. What is asked in this question? In this question, it is given an inviscous fluid, that is non-viscous fluid, with a density of 1000 kg per meter cube flows steadily through a horizontal pipe with a change in diameter. Okay. So at a certain section the diameter is, so in a section the diameter is given, the pressure is given, and in section 2, so two sections are there. In one section diameter and pressure is given, and in another section diameter is given but pressure is not given. So you are asked to find the pressure at the section 2. So see, if pressure is given, so you know that you need to apply this Bernoulli's equation. So please try to solve this one. So I am giving you 3 minutes time. Up to 4:40, you just try to answer this one. Please try to. So in this question, as pressure is given, so you need to apply this Bernoulli's equation, and also something regarding this velocity is there. So maybe the continuity equation is also required. So let's check. So 2 more minutes. You just try. So let's try. I'm giving 1 more minute. So it's a tricky question. I think that if you try, you will be easily able to answer this one. So Shivam has responded option D. So okay, let us solve this. So in this question, first I am writing what is given in this question. So so it is talking about a horizontal pipe with a change in diameter is there. Okay. So initially the diameter is small, then it is zero point 0.1. Initially it is zero point 0.1, then it goes on increasing to zero point 0.2. So that means this types of pipe is there, right? So in this pipe, they are talking about two sections. This black line represents this is section 1, this is section 2. Okay. So what is given? So initially diameter 1.1 meter and diameter 2 this is zero point 0.2 meter. Pressure is given, that is P1 is given as 200 kilopascal. Kilo means 10 to the power 3. P2 is not given. Also velocity is given. V1 is given as 2 meter per second, but V2 is not given, right? So I need to calculate the pressure at the section where the diameter is at. See, P2 is not given, but V2 is also not given. So first I need to find out this V2. So as the diameter is given, so I can easily find out this V2. How? I can apply this continuity equation, right? Continuity equation. What is there? So see at this section, if this one is the section, so I can write at the section 1, what will be the mass flow rate? Rho A1 V1 equal to rho A2 V2. As this is water, so this rho should be cancelled out. I need to find out V2. So what is V2? V2 means A1 by A2 into V1, right? So what is A1 here? The diameter is given. So I know that it is a circular diameter. So pi by 4 into d1 square. d1 means zero point 0.1 square. Similarly for A2 it is pi by 4 into zero point 0.2 square. And V1 is already given as 2. say 0.1 square, so that means 1 by 4 into 2. So 2 by 4, that is half, 0.5 meter per second. So I get V2 equal to what? In place I can write 0.5 meter per second. Up to this it is clear. Okay. Now I am applying this continuity equation. Say at applying this Bernoulli equation at 1. What I will get? P1 by rho g. I write it by green color. V1 square by 2g plus z1. Similarly, at this point I can write P2 square by rho g plus V1 V2 square by 2g plus z2. See, if I talk about this is the reference line, say see if this line and this line both are at the same distance, so z1 and z2 both are same, right? So these terms and these terms are cancelling out. Okay, these two terms are cancelled. So already P1 is given. You can put in place of P1 200 into 10 to the power 3. Density I know it is 1000 into G. You can put 10 or 9.81, whatever you feel good for the calculation. You just put. V1 is given 2, so and G also 10. Similarly, these all these values are no. So then you can find out this value. So ultimately what you will get, you will get P2, if you calculate equating 1 and 2, you will get P2 equal to something around 201.875 Pascal. So converting it into kilopascal, I got it as 201.8 kilopascal. So the correct option is option D. So you understand this concept. So this is an who answered it? Shivam. Shivam have answered it correctly. Is option D. So this type of question is quite important because initially I have to find out this V2 using this continuity equation, and after that I will be able to utilize this Bernoulli equation at section 1 and 2. That means this energy had at both the sections should be equal, and using this concept I find out this thing. Okay. So I am moving to this next question. So it's a quite long question where the main thing is about this Bernoulli equation. Such types of question is quite important. So in one of this slide I have discussed about this assumption of this Bernoulli equation. So if you remember this thing, then you will be able to answer this one. So I am giving you 1 minute time to answer. So let's try. Shivam has answered option D. Mm, So I think only Shivam has answered. So C. So if I talk about this assumption of this Bernoulli equation, what are those assumptions? The first is it should be a steady flow. Next is it should be an ideal fluid, right? Third is it should be an irrotational flow. Fourth is it should be non-viscous, that means in-viscid fluid. Fifth is flow is along the streamline. Flow is along streamline. Six is it should be incompressible. I think I have explained this earlier. So say let us compare now with the first point. Bernoulli's equation is applicable to incompressible fluid, that is 6 point. So it is right. The flow must be irrotational, that is third point. It should be right. So next is the gravity force, the pressure force, and the viscous force are considered. See this viscous force, it is in viscous fluid, so no terms of viscosity should be there. So this third option is wrong. So for rotational flow, the Bernoulli's equation can still be applied, but along the same streamline. So see, it is in the given that the flow is along the streamline. So yes, it can be applied. So though it is for rotational flow, this equation can be applied, but it need to be along the same streamline. That's why it should be applicable. Heat transfer into or out of the fluid should be zero to apply to this Bernoulli's equation. Yes, because it's an ideal fluid. So we have to consider no losses should be there. That's why here into should be zero. So there should be no losses. The Bernoulli's equation is applied for both steady and unsteady flow. No, it should be always steady flow. This is the first point. So option 3 and so 3.3 and point 6 are wrong. So option A cannot be answered. B cannot be answered. 6 is also C cannot be answered. So option D is the correct option. So that is all options are. So no need to check. This is also wrong. So option D is the correct answer, and Shivam has answered it correctly. So another concept I will I want you to solve. So this is regarding a pitot tube. So this is the last question for today. So in this pitot tube, what basically the pitot tube do? It just measures the velocity of flow. So this static pressure head and this stagnation pressure head is given. So you are asked to find out the velocity of flow. Okay. So please try to answer. So I'm giving you 1 minute of time. So please try to answer. So before this, let me clarify a thing for you. What basically is this static and stagnation pressure is? So static pressure, if I talk about this static pressure basically refers to the actual pressure felt by the fluid in a motion. So say if a fluid is in a motion, so whatever be the pressure, that pressure, whatever be the thermodynamic pressure, that pressure is known as static pressure. Okay, so I can write it as pressure felt by the fluid in motion. Okay, so another is stagnation pressure. Stagnation means pressure means it is the pressure of the fluid if it is at rest. So it is a pressure when fluid is at or brought to rest. When fluid is brought to rest. Okay. See, can you tell which pressure is more? Either static pressure is more or stagnation pressure is more? Because one pressure is related to velocity and another is at rest. So this stagnation pressure that is at rest, the pressure should be more. Why? Because from this Bernoulli's equation we know there are basically three energy terms. So forget about this datum term. Consider at 2 point these datum terms are equal. So the pressure will be more if the velocity is less. As the velocity is zero, so the pressure is more. That's why the stagnation pressure is more compared to this static pressure, right? Okay. So I'm just erasing this thing. So if the stagnation pressure P stagnation minus P static, so if you minus you will get the dynamic pressure. So that is known as our dynamic pressure. Please remember this thing. This is known as our dynamic pressure. So now try to solve this question. So both of you please try. Okay. So see, so I'm no what Shivam says that he has no idea. So okay, I'm solving this one for you. Just have a look. What exactly this concept is. So, so two sections are there. If you remember, no need to remember other things. Say one is static. Static means velocity. Say this one velocity at these 2 points V1 and V2. So you need to find out the velocity of the flow. So this is V2. Say V2 you need to find out, and V1 means the stagnation pressure. Okay. So pressure head is given. That means in these cases P1 by rho g is given as 6, right? And P2 by rho g is also given as 4.5, right? There is no details on Z1 and Z2, so that means I consider Z1 equal to Z2. So if I apply this Bernoulli's equation, what will I get? P1 by rho g plus V1 square by 2g plus Z1 equal to P2 square by rho g plus V2 square by 2g plus Z2. So that will be the thing. So see, so I can write this V1 is 0 and these two will cancel out. So I can write V2 square by 2g, this equal to P1 minus P2 by, okay, so this V2 is equal to 2g into, so this term is given, so P1 by rho g minus P2 by rho g, so that will be given. So V1 square. So accordingly I can, if I, that means here a root will be coming if I forgot about this 2. So CV is given. CV is a correction factor. So I know that this correction factor is coming from here. So it is before this 2g into P1 by rho g minus P2 by rho g. So that is the thing. So you put the value and just calculate, right? So try to calculate this thing. So that is the concept. Okay, so if you solve this thing, so what you will got? So you will get CV as 0.92 and this is say 2 into say consider G as 10 and this one is 6 minus 4.5, that is 1.5, and you will get answer near about 4.9 something, so that is equivalent to 5. So the correct option is 5. See, basically it's only the Bernoulli's equation, right? So this option B is the correct option. So just the thing is that you need to know the difference among these two terms, that is the pressure head and the stagnation. So this static pressure head and the stagnation pressure head. So this is two line. I just repeat this thing. So this stagnation, say this is stagnation and this is static. Okay, stagnation means this velocity here at is equal to 0 and stagnation means there is some certain velocity is there. So that is the thing, it is given here. So this pressure head is given, right? This value is given and this value is also given, pressure head. So the static pressure rate is 4.5 and this is 6. So that is the concept. Okay. So that concept is used here, and as no details about Z1 and Z2 is given, that's why I have considered this thing as same. So I am repeating this thing for you. Okay. So after that you can calculate V2. So V2, using the Bernoulli equation you can calculate V2. Since a correction factor is there, so whatever be the actual V2 value is coming, you have to multiply it with 0.92. So that's why I get option B as the answer. So up to this, any confusion? So I think this concept is clear to all. So this is for today's class. So any confusion, if there is no such confusion, you can leave the class. So okay, I am just okay, Shivam. Thank you for responding to this class. Have a good day. Bye.